My name is Ray Kopp from Resources for the Future, and I want to thank everyone for attending this research presentation this morning. We have several research institutions that are participating in this. My own institution, Resources for the Future, the Research Institute for Innovation Technologies for the Earth, RITE, from Japan, Duke University, Harvard University, and the Fondazione Enrico Mattei from Italy. And so again, we have a broad range of expertise on hand today, and we thank you very much for your attendance. The way we're going to run is I'll give a brief overview of some research results, and it's important to recognize that these are very recent research results as of last night, and we're still working on them. We do not have a formal paper to provide you at this time, but that will be forthcoming, hopefully in mid-January or so. But we wanted to give you a taste of the sort of results that we're generating at this important event here in Paris. So I believe it's probably safe to say that starting in Copenhagen in 2009, and perhaps earlier with the Bali roadmap, the methods and procedures by which the world is going to collaborate and coordinate on climate change has been altered. We are now moving to an old term in the statecraft view, which is called pledge and review. Rather than taking a fixed carbon budget and allocating it across countries, we're now allowing parties to the Framework Convention to come forward and pledge effort on their parts with the intention that in doing so, we will gain more comprehensive inclusion of parties, and hopefully over time, the ambition of all those parties will increase. Pledge and review is, I think, going to emanate and be identified as the procedure of choice coming out of Paris. And the question is always going to be, how effective will pledge and review be going forward over the next several decades in ensuring that we meet our climate goals? And so it's incumbent upon research institutions, like the ones presented today, which are, for the most part, economist-based, to try to support that process to the best extent possible. And so the research that we're going to unveil today is really designed to support pledge and review going forward in a couple of different ways. For a pledge and review process to be effective, obviously the pledges have to be transparent. That is, all parties to the pledge negotiation have to understand what their counterparts, their peer nations, are pledging in transparent terms. Importantly, also, you have to be able to evaluate the pledge of your peer country against your own pledge. If everyone was pledging the exact same thing, that would be a trivial task. But the pledges, as we'll see and as we know, are very complex assemblies of different policies, and it's not an easy, straightforward comparison to understand whether the nation sitting across the table from you is pledging a series of activities that, in terms of level of effort, is equivalent to your own. And so you need to make that assessment in a formal negotiation. Then it's going to be certainly important, after the pledges have taken place and some time has lapsed, that those pledges can be evaluated in terms of the on-the-ground reality. Did countries actually accomplish what they pledged to accomplish? And so there's both an ex-ante analysis of the pledge when it's forthcoming, to understand the level of effort each country is putting forward, and then there is an ex post, after the fact analysis. Did you do what you said you were going to do? And what we've been working on right now is the ex ante analysis, and ex post analysis will certainly be important coming forward. So this first slide just basically reiterates what I said. There's research that's been done on a normative basis that suggests what countries should do, what their INDC ought to look like. What we're doing is taking the actual INDCs and trying to understand what countries say they will actually do. And this, again, is to provide the pledge and review process with concrete information about the levels of effort involved in those pledges when those pledges are made. This turns out to require economic modeling, primarily because the pledges are very diverse. Countries can pledge emissions relative to different kinds of base years, relative to GNP targets, intensity, and what have you. And many of these particular activities will require economic modeling to convert to common base formats. And so since we have a vast amount of economic modeling here, that's why we've been involved in this. It's also important, I think, to have at least some third-party verification or third-party analysis of these INDCs. Each country will tell you what it thinks its INDC is going to accomplish and the level of effort it believes it's undertaking with respect to that INDC. But as we can imagine, those country analyses may be selective in terms of how they present themselves, and they may not generally allow for this country-to-country comparison, which we think is important. It's also the case that if countries only look at what they're doing and don't take into account the broader economic impacts of one country's effort on another country, they're going to miss, again, a lot of the importance. And so these inter-country effects are important. And lastly, I believe that since countries are adopting very different policy mechanisms to achieve their end results, there's going to be an opportunity to look at those policies in terms of their cost effectiveness, their environmental efficacy, compare them across countries, and perhaps learn a little bit about what sort of policies are most effective and efficient. So to do this, we're going to need some metrics, some things that we can use for comparison. And so we've established 3 principles for deciding on metrics. One is comprehensiveness, and the idea that we want to capture this notion of effort in as broad a possible framework as possible. The idea being that similar countries might be expected to exhibit similar effort levels going forward, and so we want to make sure that what we're calling effort is broad-based. The metrics need to be measurable, either directly observable from facts, or they need to be derived from transparent analysis that can be replicated by third parties. And so this third-party replication, we believe, is crucially important. And at the end of the day, these metrics need to be universal, and that is applied to a very broad set of policies and a broad set of countries. So the metrics that we've developed, and actually were rolled out a year ago at a similar event in Peru, go from the simple to the most advanced. Simple metrics are easily measured and replicable. For example, pledged emission reductions against a base year. That's something that is quite straightforward. More advanced metrics require, rather than facts, some modeling and some forecasting. You can see emission pledges pertaining to future years, emission pledges relative to GDP. Those are more complex. And then the most advanced metrics do require extensive modeling, but turn out to be the most informative. For example, impact of pledged actions on energy prices. You'd like to know what happens to electricity and natural gas and other sorts of energy prices within an economy. You obviously want to know the marginal cost of abatement within a particular economy, given its INDC. And we'd like to know the overall cost of meeting any particular pledge in terms of its impact on GDP. So we're going to develop a series of those metrics and deploy them. What we've chosen to do is use 2 modeling frameworks. The WICH model is maintained and designed and maintained by FEAM in Italy, and DNE 21 Plus is a model designed and maintained by Wright in Japan. And I won't go through this slide. It gives you some idea of the difference between those 2 models. There is one very important distinction in addition to the kinds of regions that the models undertake and how they treat trade and forestry. The Wright model is a very detailed, what economists call a bottom-up model, which begins with an enormous amount of detail about the energy sector. and energy technologies, and from that builds up to larger scale macroeconomic impacts. The WICH model is what economists call a top-down model, and it begins with a very broad discussion of technologies and moves down through the economy. These models tend to give different results because their paradigms are really different. Not that one is right and one is wrong, but they tend to give different results, again, based on these parametric differences. We chose those two to try to help bound a little bit the analysis. It would be great to add more models going forward of both kinds and to give us a more rich view of these results, but we think this helps bound the analysis sufficiently for the work we want to present today. So let's. This is a very busy table, and I don't want to go through it. I just want to identify that the columns in this table are some countries and the EU as a region. So we have the U.S., the EU, China, and India. Below those columns, there's a column for the WICH model and a column for DNE 21+, and then the rows are different metrics. So let's highlight a couple of metrics. The first one would be if you looked at the INDC of these various regions and you compared that to what their baseline emissions would look like between 2025 and 2030, and it's an average over that time period. Take the first column under the U.S. under WICH. The WICH model suggests that U.S. emissions would be 39% below the baseline, okay, below the business as usual baseline, given the INDC the U.S. has put forward. DNE 21, a very similar number, 35%. The EU, in the neighborhood of 30 to 32%, models give very similar results. As you move to China and India, the models begin to diverge for a variety of reasons, and we have the modelers here, so they will answer your questions. I cannot. But I'm just here to give you the overview. Let's look down at the marginal abatement cost, which is something that economists spend a lot of time worrying about. This is in dollars per ton. This is in U.S. dollars per ton. And so for the WICH model in the U.S., for the U.S. to achieve its INDC in 2025 to 2030, somewhere around $100 a ton. DNE 21, same number, about $100 a ton. The EU, higher. 120 to $150 a ton, and then when you get to China and India, the numbers fall rather dramatically. Depending upon what model you're attracted to, the range between $0 and perhaps $20 a ton in marginal control costs. The next line just shows electricity price increases in percent, and you can see how electricity prices in the EU and the US would rise rather substantially, and in China and India, they're not expected to rise much at all. Perhaps they might even fall. This next table shows, again, how you might use these models, a little more disaggregation. So we have a different set of regions. The first one, Canada, Japan, and New Zealand. Then Japan alone, since DNE 21 does model Japan as an independent nation. Then we have Korea, South Africa, and Australia, South Africa, transitional economies, and Russia. And again, if we take a look at some of the metrics there, let's take a look at the marginal abatement cost. You can see for the Canada, Japan, and New Zealand, under WICH it's less than $50 a ton, but under DNE 21, it's more like $200. So the models are giving very different results there. And the model for Japan, DNE 21, has a very high marginal control cost, just under $240 a ton. So let's take a quick look at this diagram. What this shows you on the vertical axis is mitigation cost in terms of percent of GDP. The horizontal axis is the emission reductions provided by the INDC as a percent of business as usual. And so if you look at the dots, starting with India, there's a blue dot down there in the lower left-hand corner, and a line connected to a larger dot further up. Those two dots represent the two model results, which being the result on the high end, and Right, and DNE 21 is the one at the low end. So you can see how the two models actually relate to one another in terms of their cost in terms of GDP. The important thing to draw from this is not so much how the models vary, but that increased ambition in terms of emission reductions is highly correlated with increased cost of attaining those reductions. As your ambition goes up, your cost goes up across all of these countries that we've modeled. The second diagram lays out the same way. The lines connect the two model results. And here, again, we have mitigation cost on the vertical axis, but on the horizontal axis, we have some measure of the wealth of nations in terms of income per capita. And the idea of this is to associate the level of cost incurred by different countries and how that ties in with their income. The idea being we would expect that high-income countries to have higher costs than low-income countries, and that's roughly what we see in this diagram as well. The INDCs seem to have some sort of progressivity involved in it, that the more affluent countries are undertaking greater actions in terms of control cost. I'm going to close with this last diagram, which displays from the models the marginal control cost. The red and blue differentiate between the WICH model and the DNE 21 plus model. But what's important here is to understand and to recognize the differences in these marginal control costs. They range from very small numbers, okay, to very large numbers. What we've imposed on there is that horizontal red line is an estimate of the social cost of carbon. Some of you may be familiar with that, some of you maybe not, developed by the US. But what it basically says, if you try to quantify the marginal damages of a ton, it would be somewhere in current dollars of $50 to $55 a ton. And you can see many countries are below that and many countries are above that with respect to their marginal control costs. This suggests, from an economist's perspective, that there is an enormous amount of gain from trade. Okay. If there was a mechanism that allowed for countries with very high control costs to buy tons in countries with very low control costs, everybody would be made considerably better off. And this is something that we believe for a long time, and these models continue to show that with respect to the pledge and review. I'm going to stop now, turn this over to Carlo Carrero, and he's going to go just one level down, and then we're going to bring the modelers in to discuss this in more detail. Thank you. Carlo?
Good morning. I have to leave in a few minutes to speak in another side event, and will not be able to remain here to answer your questions or remarks, and I do apologize for this, but I want to say a few words anyway to stress some of the main aspects of this research effort that have been carried out by our research institutes, so Resources for the Future, and then Wright and FEAM, but also Duke and Harvard as our partners of this important research effort. We launched this activity a few months ago when the first INDCs have been published. Then we've been updating the analysis and the results over the last weeks in order to come here with a very careful assessment of the INDCs, not just with respect to the standard metrics that you all know in terms of changes with respect to 2005 or 1990, but also changes with respect to the business as usual calculated by the two different models, and the economic assessment, which is not something that you find in other studies, because evaluating the INDCs in terms of costs and marginal costs is a very important information which is missing, was missing, and we've been able to provide. The main objective starts from this IPCC diagram. We all know that emissions have been increasing over the last 40 years. They've been increasing more and more because the rate of growth has been larger in the last 10 years than in the previous 30 years. So this kind of situation cannot continue. We all know that this kind of situation cannot continue. We knew that for the last 30 years. We've been negotiating about emission reduction for 30 years without succeeding in controlling emission changes. Emissions have been increasing, and negotiation have been unable to deliver anything close to a stabilization, not even a reduction, but a stabilization of emissions. So something must change. The INDCs can be a first step towards this change. Maybe they can be an important step, because the objective is really to stabilize, or at least get rid of this growth rate of emissions. But is it true? The answer comes from this study. I'll show just a few numbers, because then both Keigo and Massimo will deliver a more detailed presentation of the results coming out from the WICH and the DNE 21 plus model. But we know that we have 158 submissions, 185 parties have submitted their own INDCs, and these INDCs are quite different. I mean, Ray already stressed the fact they are very different in terms of descriptions of the pledges that the different countries have submitted to the UNFCCC. Sometimes reduction targets are clear and absolute. Reductions are not measured with respect to, say, BAU or GDP or whatever, so it's easy to assess how many tons of carbons we can achieve in terms of reduction. But in other cases, this is quite complicated, because we need to project BAUs, we need to project the energy mixes for different countries, and so on and so forth. So this work can be done only through economic models, and this is what this research project has been able to achieve. The questions that we would like to answer are mainly three questions. Are these INDCs effective, in particular effective in getting closer and closer to this C-degree pathway? Are they consistent with the optimal emission reduction pathway that could lead us to 2 degrees? Are they equitable? Are they fair? Is the reduction, in particular the cost of different reduction effort, allocated to different countries in an equitable way? And finally, and this is what Ray stressed at the end of his presentation, are they efficient, economically efficient? Is the cost of achieving this emission reduction minimized? So these are the questions, and as you will see, the two models are able to answer these questions, even though in different ways, quite precisely. The main information is this one. The red line is the BAU. The blue and green lines are the INDCs. There are two lines, because you know that some INDCs are conditional on financial support. So what we call INDC up are those including absolute and relative INDCs, and including also those conditional on financial support from developed countries. INDC low identifies the INDCs without the conditional efforts. And you can see that with respect to the BAU, what we get is a reduction which is about 20%. Most importantly, what we get is that the increase of emission, if the INDCs are implemented, is going to stop. And this is certainly a major achievement of the Paris Agreement. Of course, not enough, probably not enough to achieve anything close to the 2-degree target, but again, a major step, because the trajectory, the optimal trajectory is this one. As you see, the blue lines identify the clouds, so optimal trajectories consistent with the 2C target, and the INDCs are not perfectly consistent. Probably the peak of these emission trajectory should have been achieved before 2030, but even achieving the peak in 2030 and then going down quickly remains feasible, so we're not completely inconsistent with the 2C trajectory. The second information about equity comes from this table. Keigo will tell you more about this, but shows how costs are quite different. Costs of reducing emissions are quite different and are higher in developed countries and much lower in developing countries. So there is some equity in the submitted INDCs. And finally, marginal costs. These are the marginal costs of the two models, the DNE21 plus model on the top, the WICH model on the bottom. And again, you see how different are these marginal costs across the the different countries and regions, which implies there are gains from trade, possibility of improving in terms of economic efficiency, and reducing the cost of achieving the INDCs. So, just to conclude, the assessment, of course, this is something that I put forward for discussion and further questions, but certainly we believe that starting with this preliminary assessment, the INDCs are an important achievement of negotiations. They are effective in stabilizing emission, in controlling emission, even though not yet in reducing emissions. They contain some degree of fairness. They are not efficient in terms of economic efficiency, but certainly this can be improved because the actual implementation of the INDCs will see the emergence of many possibilities of trading and, of course, of gains from this kind of inefficiency that leads to economic opportunities for many countries and regions. I would like to stop here and give the floor to Keigo, who will present the results from his model in a very detailed manner. And thank you.
Keigo, why don't you take a stand?
Good morning, ladies and gentlemen. I'd like to make a presentation right evaluation on emission reduction efforts of the INDCs and the expected global emissions. So first, I'd like to talk about the main ideas and assessment framework, but most of the all was covered by Ray and Carol. So I'd like to touch upon just only the third point. This is not a top-down approach using the emission allocation indicators in line with the 2 degrees target or the 450 ppm target. However, we calculate world total emissions taking into account all the countries' INDCs. So I'd like to explain the overview of our global warming mitigation assessment model, DNE21 plus. In this model, the indicators for measuring the emission reduction costs, we adapted the DNE21 plus model. In this model, energy-related CO2 emission reduction costs can be estimated with consistency. This model is a linear programming model, minimizing world energy system costs between 2000 and 2050. The world is divided into 54 regions. And interregional trade, for example, coal, crude oil, natural gas, electricity, ethanol, hydrogen, and CO2 were considered. And bottom-up modeling for technologies both in energy supply and demand sides considered. So the detailed assessments by region and by sector are possible with consistency. Okay, next I would like to talk about the employed indicators for our assessment to measure the emission reduction efforts. For example, emission reduction ratio from base year, but compared to 2005 and compared to 2012 or 2010, and the emissions per capita, CO2 intensity level, not only for absolute value, but also improvement rate, and the emission reduction ratios compared to BAU, and the CO2 marginal abatement cost, retail price of energy of electricity, city gas, gasoline, and diesel. and also emission reduction cost per GDP. But there are no silver bullet indicators to measure the emission reduction efforts, so we need to use the prompt indicators, as you can see here. So there are all of the indicators has merit and also a demerit. So this is the, we evaluated the 119 INDCs submitted as of October 1st, 2015, which covers about 88% of global emissions in 2010. And the comprehensive evaluations of emission reduction efforts were only for 20 countries due to the limited regional resolution of the model, as you can see here. But I'd like to skip here. Okay. So this is a caveat of the assessment of our assessment of the INDCs. For example, LULUCF emissions are not taken into account. LULUCF emissions and also emission reductions are not taken into account for international comparisons of mitigation efforts because they have large uncertainty and their appropriate evaluation is difficult. And for the countries with emission reduction targets compared to the base year, the emissions in the target year are calculated based on the historical emissions excluding LULUCF. And the historical emissions are derived from Japanese greenhouse gas inventory for Japan and the UNFCCC inventory for other Annex 1 countries and IEA database for other countries. But I have limited time, so I would like to skip this. But the final point, for Brazil and Indonesia, who are large emitters from LULUCF, only the three indicators, emission reductions compared to the base year, emissions per capita, and emissions per GDP are evaluated, including LULUCF for the two countries. So first, I would like to show the emission reduction ratios from base year of 2005. This indicator is the for Switzerland, Norway, and the EU is better numbers, but India is poor. But this is strongly depend on the economic growth rate, so we should take care of the interpretation of these indicators. Meaning. And so I'd like to show you the GHG emission per capita for the INDCs. In this indicator, Switzerland also a better number. Okay. So this slide shows the GHG emissions per GDP. In this indicator, in Switzerland, Norway, Japan, EU is better. In this indicator, but this GHG emissions per GDP also depends on the economic industrial structure for the different across countries, and so we should also take care of this indicator also. So this slide shows the emission reduction ratios compared to BAU. But if we estimate these indicators, we also estimate the BAU emissions by using models. But so this is also have large uncertainty. But this is also a very important indicators to measure the emission reduction efforts. In this indicator, Switzerland, Norway, Thailand is a better number. But Ukraine and for Ukraine and Turkey is a negative number. That means below the baseline. These targets are below the baseline. Okay, and this is the CO2 marginal abatement cost. For example, in Switzerland, the marginal abatement cost is $380 US per ton CO2, and also for Japan, and for EU, $100 per ton CO2, for example. But for Turkey, India, Ukraine, and China, it's almost zero carbon price. Okay. So this is the retail price of energy, of electricity. Marginal abatement cost is a additional cost compared to the baseline. But we also see the retail price of energy to measure the emission reduction efforts. So EU is the best number in this indicator. So finally, this indicator shows the emission reduction cost per GDP, as already Carol showed. So Australia, Ukraine's high cost per GDP, but for some countries, zero number. So finally, this graph shows the ranking index of emission reduction efforts of INDCs by indicator, such as emission reduction ratio from base year, emission per capita, emissions per GDP, etc. So for many indicators, excepting emission reduction cost per GDP of Switzerland, Japan, and EU, were evaluated to have high rankings. CO2 marginal abatement cost of Australia is not high, but the emission reduction cost per GDP is large. Okay, finally, I'd like to talk about the expected global GHG emissions of the aggregated INDCs and the corresponding emission pathways up to 2100 toward 2 degrees goal. As you can see here, the expected global GHG emissions in 2030 is about 60 gigaton CO2 equivalent when all the submitted INDCs are achieved. That means it corresponds to the about 6.4 gigaton CO2 emission reductions from the baseline. The expected temperature change in 2100 is 2 to 3 degrees Celsius rise from pre-industrial levels. The range depends on the uncertainties of climate sensitivities and on future deep emission reductions through developments and deployments of innovative technologies. For the 2030, it is important to induce the achievement of INDCs and further emission reductions for countries having room for more reductions through PDCA cycle. And beyond the 2030, it is important to seek deeper emission reductions through development and deployment of innovative technologies. So let me summarize as follows. We evaluated the emission reduction efforts, the degree of ambition of INDCs from various aspects using multiple measurable indicators. Many indicators of Switzerland and Japan were evaluated to have high ranking, and the US was in the middle with respect to many of the indicators. However, this result should be interpreted with care because the US target year is 2025. This is a slightly different late summary showed the average value of 2025 and 2030. For several nations, such as China and India, marginal abatement costs were evaluated at zero, meaning the INDCs are to be realized BAU according to our socioeconomic scenario. So there is no single absolute indicators measuring international fairness and equity, and our study is no exception. Rather, it should be regarded as one of the evaluations that are usefully taken into account in PDCA cycle. So global emissions will be 60 gigaton CO2 equivalent in 2030, according to our analysis, if all the nations realize their submitted INDCs. The emissions are considered to stay on the pathways of 2 to 3 degrees temperature rise in 2100. There are some differences in the estimates of 2030 global emissions among studies, but this is due to the differences in expected BAU emissions for nations whose INDCs are expected in emission reduction ratio relative to BAU. And in addition, our study takes into account the carbon leakage effect that is caused when marginal abatement costs are substantially different across nations. And finally, estimates of temperature rise vary widely due to wide uncertainty of climate sensitivity and also assuming innovative technology development and diffusion, and large emission reduction correspondingly brought about by them in the latter half of the century. Thank you very much for your kind attention.
Max?
Thank you very much for being here in this very busy day. Thank you to Keigo for organizing this special event here in the Japanese pavilion. I'm the last one, and I will try to conclude giving you some additional insights of what the other speakers have told you about model results from the INDC, mostly coming from our perspective, our own modeling results. So taking it from where Carlo was, the key questions for INDCs essentially are three. How effective are they? How efficient are they? And how equitable? I guess these are the three metrics against which we have to compare INDCs. So we try to answer these questions, and we do so using an integrated assessment model. You heard already about it. It's called WICH. It has been used prominently in the IPCC fifth assessment report, where it was one of the models which contributed the most of the scenarios, which are, by the way, publicly available on the IPCC Working Group 3 website. We simulate high and low pledges, as you've seen already. We also simulate a case, and I show you the results, where you assume there's trading between regions. So the pledges and the mitigation that goes with that can be actually traded among regions to tackle the question of efficiency. And of course, to tackle the question of effectiveness, we also have to project INDCs forward in time. INDCs have a deadline of a particular time horizon, which goes from now to 2030. Temperature is measured by the end of the century. So there's a huge gap for which we need some projections forward in time. So let me try to answer these three questions: effectiveness, efficiency, and equity, similar to what Carlo was saying before, and indeed starting from a similar chart that Carlo had. So these are the INDCs. It's the same chart that Carlo showed you before. In red, we have the business as usual, global emissions up to 2030, and then we have the pledges high and low, which show a significant reduction in emission, non-negligible reduction in emission with respect to BAU, and emissions slightly up higher than today. Now, of course, when you compare it to the 2-degree scenarios that come from the AR5 database, these are about 1,000 scenarios that are in the AR5 database, a subset of those, but many of those, as you can see, many of which generated by the same models, consistent with 2 degrees with some likelihood. You see that this range is slightly above, or significantly above, the actual median in 2030. Now, of course, most importantly, what will be the implication of INDC depends on what happens post-2030, not up to 2030. There's a lot of focus on 2030, but the key question here is how those will be carried forward in time. And that will ultimately determine what kind of temperature the world will be confronted with at some point in the future. So there are many ways to project forward. Here you see different ways of projecting forward, assuming either that the pledges are continued and extrapolated with the rate of growth of 1% per year. So you take the intensity of the pledge in terms of carbon price, and you let it grow every year a little bit. 1% is not a lot. And those are the red ones above. Then, assuming that the carbon prices are extrapolated at 3%, so every year the intensity and the effort in terms of cost grows 3% per year, and those are the green. And then assuming that they grow at 5%, so that's a higher intensity. Now, if we do so, you see there's a big range. It depends on on how much they're going to grow, 1%, 3%, 5%. Also, whether they're going to start from high and low pledges makes a difference. However, in all cases, you see a gap. You see a gap between what would be the outcome of the pledges and what would be consistent with 2 degrees. So we're talking about scenarios which, if extrapolated forward with these rates, 1 to 5%, would generate temperature by the end of the century, which are certainly above 2 degrees and above 2.5 degrees, and also in several circumstances above 3 degrees. So between 2.7 and 3.5 degrees, as discussed in policy context, you see that range. That range is exactly covered by how much are we going to go and extrapolate forward in time the pledges post-2030 in terms of intensity. But the gap remains between 2 degrees. So the real question is not so much about 2030, but how to envisage mechanism for which we can intensify the rate of ambitiousness post-2030. And that's the first question regarding effectiveness. Now, regarding effectiveness, however, there still will be significant investments in 2030. This is a chart showing you the global electric capacity in the power sector in 2010 and expected in 2030 under the INDCs as projected by our model. And what you see is that with this level of ambition of the INDCs, as we see them today, there's a large increase in investments and capacity in, of course, lower carbon sources. So especially renewables, which are now the third or in terms of total capacity installed between different sources, will become by far the first one. You see the bar in renewables, which increases quite dramatically. So by 2030, installed capacity in renewables would be the first. Renewables would have the largest installed capacity. It doesn't mean production, it means capacity, just to be clear. Then gas would come in second, as it is already today, but with significant increase. There would still be increase for coal, actually, in these scenarios, because some of the countries which have very low pledges would invest in coal. There will be a very little amount of coal with CCS. I'm not showing it with carbon capture and storage. I'm not showing it here. There would be a small amount of investment. But mostly, essentially, we see essentially a shift away from coal towards renewable and gas, as expected. So it's still a significant change with respect to today, even under current INDCs, and these are the low pledges, not even the high pledges. Now, where these investments in renewables, for example, would come from, most of the targets INDCs are in the OECD, US, Europe, Japan, Switzerland, and other countries. So actually, most of the installation by 2030 would happen in the OECD, which is half of that cake, essentially, of renewable installations in the year 2030 would be installed in OECD country. A large fraction, about a third, would be installed in Asia, of course, given its big size, but also in reflection to the fact that some countries, such as China, and of course other countries, have put forward targets which foresee significant investments and the shift towards renewables. Of course, a larger and more comprehensive agreement, which would involve more targets from the developing world, would shift the balance towards away from the OECD towards the non-OECD. But since the INDCs are very much centered, as we've seen, and as it is fair on OECD, a lot of installation will come from that region. But we're talking about very large numbers in terms of capacity building up. So it's still, in terms of effectiveness, it's not a small amount of effort in the INDCs if you think about the capacity and the investments that go with capacity, I would say. by the year 2030. Of course, it can be done more, and the geographical balance is not perfect, but I think this is a good start. Now, efficiency. Efficiency is less of a good indicator. We see the prices here again. We've seen this. Carlo showed this, Ray showed this, and Keigo showed this. The prices of carbon implicit in the NDCs are all over the place. They're very high, they're very low, they're zero. And here I'm also showing you a line. You see the dotted line. That indicates the carbon price that we would have in this system if we were allowed to countries to trade CO2 freely with no restrictions. That's, of course, an idealized case. Then there could be in-between scenarios, but in the idealized and limiting case in which there would be free trading of CO2 permits with these INDCs, the price of permit that would emerge from our model is below 20, is about $16 per ton of CO2. Now, this number is below the social cost of carbon of 53, which tells you that this agreement in itself is not particularly effective. But it also tells you that, of course, there's a lot of potential from trading. And, of course, there's efficiency gains to be made by those countries who have carbon prices which are higher than 16. And in a system like this, those would be countries who would buy permits on the market at that price. And, of course, there's revenues to be made by those countries which are below those $16 per ton of CO2. And those would be the countries who would be under such an agreement willing to sell CO2 permits. But the differences between those dots and that line tells you about how much we can gain in terms of efficiency. We can get to the same point with lower costs. Or we can get to a higher and more ambitious target with the same costs. Now, of course, this is a full trading system. It requires issues about compliance and verifiability. It's an extreme case, but of course, the reality is probably in between these two extreme cases. That's for efficiency. And let me skip this. Let's talk about equity, because that's also a very important dimension. Equity is as important as the other two dimensions. What I'm showing here is a similar graph than what Ray showed before, but now I'm showing it in GDP per capita against marginal costs. And as you see here, the richer countries, the countries that have high GDP per capita, which are on this side of the chart, have marginal costs which are higher. And countries with lower GDP per capita have marginal costs which are lower. So I think Ray showed that for GDP cost. I'm showing it for marginal cost. For marginal costs, it's even clearer. It's actually a relatively fair process. 10% richer, 7% higher carbon prices. So almost neutral, almost one-to-one. If your country is twice as rich than my country, you have a carbon price which is more or less twice as high as in my country. The perfect would be one-to-one. It's a bit less than one-to-one, but I would say it's relatively fair and equitable in the sense that wealthier nations would take on larger obligation as measured here by the marginal cost of the cost of CO2. Now, the marginal cost is one thing, the GDP is another, because there are things in between. The economy there are issues about terms of trade, international trade. And indeed, if you do the same chart, but now you look at wealth on one dimension, and on the other dimension you look at cost as measured by GDP, now you see that it's not so clear any longer. You don't see a very clear patterns. So very wealthy countries here actually have higher cost, slightly higher cost than some of the countries here. But there are some countries which lose, for example, the oil exporting countries would have adverse terms of trade effects. And South Africa as well because of terms of trade through coal. But in general, there are terms of trade which make these pictures a little bit more complicated. So when you actually account for the full economic repercussions that a model like the models that we have can actually take into account, then fairness is not as clear as it was in the previous chart, but there are ways to compensate for this, I think. Still, there's a relation between wealth and intensity of effort, which I think goes in the right direction. So let me conclude. I don't want to take too much time out more than this, but the key questions for INDC and what are the answers? Effectiveness. I think we can say and we can claim that INDCs make non-trivial reduction from BAU, large investments, especially in renewables and in gas, away from coal, and big repercussion on investments. I think it's not zero. Now, of course, it needs to be strengthened to attain climate stabilization, either 2 degrees, 2.5. It's not so much important about what level, but we need to strengthen those in 2030 and, most importantly, post-2030. How can we extrapolate those targets and go really deep? That's really the questions that confronts us. Now, efficiency. There's large carbon price gaps. Now, that, from economists, sounds like opportunity for trading of international carbon offsets. And I think that's very clear from our charts. The prices are, in some cases, close to 100, even above 100, and 0 in other countries. The average price would be 16, so it can be reduced. If not completely to 16, there can be scope for trading. I think there's scope for agreements and trading between at least those countries which have trading systems. And of course, on the other hand, the fact that the industrialized economies have the higher carbon prices is good in a way by itself because it spurs R&D investments. The results from our model suggest indeed that there would be about $20 billion per year investments in R&D, coming in R&D in clean energy, in research and development and innovation in clean energy coming from the INDCs. Mostly because the prices are high in the countries where the innovation capacity is also the highest, such as, of course, the industrialized nations. And that is, in a way, a benefit of having carbon prices which are not exactly the same everywhere. You have more innovation than you would with a system with the same carbon price everywhere. If we can manage to have technology flow between industrialized and developing economies through some sort of technology agreement complementing the INDC, I think that would be an interesting opportunity, at least reaping off the innovation benefits coming from the fact that industrialized nations have a strong commitment and will invest a lot in R&D. How equitable? It looks relatively fair, although less so when accounting for wider economic repercussion, mostly because there are these issues with international trade, which complicate it. Of course, they can be compensated by offsets or other ways, or by border tax adjustments or other policy variables and levers. But in general, at least in terms of effort, emission reduction, and marginal cost, actually INDCs are pretty fair. So they're pretty equitable. So it looks like they are relatively effective, not as much. There's much more that can be done on efficiency, and equity is actually pretty good. Thanks.